Okay, well, I'm going to go ahead and get us started today. First off, hello, good morning, or good afternoon. With over 500 people that registered for this webinar today, I know that we have people representing multiple time zones. So ECA is excited to welcome you all to our first in a new series of informational webinars on advanced nuclear technology deployment. And what better way to start than with this introductory conversation with the U.S. Department of Energy and the U.S. Nuclear Regulatory Commission. My name is Kara Colton. I'm the Director of Nuclear Policy for the Energy Communities Alliance, and I get to be your moderator today. ECA has been around for about 30 years. We represent the local elected officials and leaders in communities hosting DOE's federal nuclear facilities and government-owned research and demonstration activities. We also have members in communities hosting commercial nuclear facilities and those interested in hosting potential new nuclear projects. And we're not doing that just here. We're also working internationally with municipal leaders in 19 other countries too. We all have a lot of the same interests and we see a lot of the same opportunities. In short, ECA, we are nuclear communities. We're looking to learn, to share experiences, and to collaborate with peers in existing and potential nuclear host communities. So that's who this inaugural event is for. Communities, states, tribes, anyone interested in advanced nuclear technologies. We're going to start with some of the basics, so no prior knowledge of nuclear is necessary to be engaged. So before I introduce our esteemed speakers, let me just quickly run over how the webinar is going to work today. The goal is to have a discussion amongst our speakers and with you. We're going to start with first moderated discussion, after which we're going to take questions via the Q&A function at the bottom of your screen. Please submit your questions there, and do note that any questions that come in will come in anonymously. We have a lot of people. We are likely to get a lot of questions, so let me apologize now if we don't get to all of them. Please submit them though, even if you think we might not get to it, because it does help inform how we go forward with other events like this. We're also going to do a little instant polling to keep things somewhat interactive and inform future education and outreach opportunities. Again, please note any information that comes in will come in anonymously. Finally, we are recording the webinar, so it will be available shortly after we conclude today on ECA's website and our YouTube channel. That is all of the administrative details out of the way. So let's get started with our first interactive polling question to give our speakers an idea of who is on the line. And that is coming up right now. And that is who is in the audience. Go ahead and check a box and we will see who is on the line. As we do that, let me go ahead and get started. Our speakers today. First, we're going to hear from Dr. Katie Huff, the Assistant Secretary for DOE's Office of Nuclear Energy, a position she's held since being confirmed by the U.S. Senate in 2022. Before joining DOE, Dr. Huff was a professor in the Department of Nuclear Plasma and Radiological Engineering at the University of Illinois at Urbana-Champaign, where she led the Advanced Reactors and Fuel Cycles Research Group. She's been an excellent champion, representative, educator, and advocate for nuclear energy and its potential to provide clean baseload power as part of an all-of-the-above energy strategy, as well as create jobs, reliability, and energy security. Joining Dr. Huff today is Mr. John Lubinsky, Director of Nuclear Regulatory Commission's Office of Nuclear Material and Safety and Safeguards, a position he has held since 2019. Mr. Lubinsky first joined the NRC in 1990 as a mechanical engineer, and since then has held multiple deputy division and division director positions in the Office of Nuclear Reactor Regulation and the Office of Nuclear Security and Incident Response. So let's see, Faith, if we have results of the first interactive question, and we can see Dr. Huff and Mr. Lubinsky. There you go. This is who you're talking to. And with that, I will get started. First question for Dr. Huff, and it's a very thematic one for our call today. Dr. Huff, what are advanced reactors and how are they different from operating reactors?
Such a great question. I think we should start that, the operating fleet, especially in the US, is resilient, it's reliable, it's carbon-free energy. It produces almost 20% of our electricity, nearly 50% of our carbon-free electricity. And we need it for energy security and to meet our carbon reduction goals. And those existing reactors are awesome. Next generation reactors are defined in a lot of different ways, depending on who you are. Most people probably adopt the definition that the Senate, one of the definitions the Senate's come out with, which largely says that these are reactors that have significant improvements compared to the most recent generation of fission reactors. And those improvements can include things like additional passive safety features, or lower levelized cost of electricity, or lower waste yields, or improved fuel performance, improved utilization, increased tolerance to, loss of fuel cooling, enhanced reliability or proliferation resistance or security, potentially reduced consumption of cooling water, perhaps no cooling water at all, perhaps advanced coolants and fuels inside the reactor, exotic materials like sodium or salts as coolants instead of water, and gas cooled reactors that are higher temperature output. A lot of the time we hear about folks talking about advanced reactors in terms of their size. Simply shrinking the size of those gigawatt scale reactors should allow for deployments that correspond to the demand for electricity in specific places with specific capacity needs. And those reactors often will also have operational flexibility to respond to changes in the demand for electricity, and that should help renewables be deployed alongside them. So advanced reactors differ from existing reactors by being, in general, improved, right? And there's a lot of different ways you can kind of slice this definition, but I think from my perspective, I think the reactors that have been, brought into the vendor space and are approaching NRC licensing or have recently gotten NRC licensing, or even the AP1000 all qualify. The AP1000 gigawatt scale designs, they have passive safety features that allow for, a lot longer period of post-accident passive safety, for example. And so I would classify the AP1000 as a advanced reactor, but not everyone would. You're muted, Kara.
Now it's an official webinar. Thank you. Sorry about that. Well, so obviously there are multiple vendors, multiple designs. So can you speak a little bit to how DOE is taking a role in the process of development, demonstration, and deployment?
Yeah, absolutely. So, it's generally the federal government's role to take on some, first mover risk around the research or development or even demonstration and deployment of new energy technologies that'll help humanity, that'll help Americans, right? And DOE has the unique opportunity to do that through research and development awards to universities, to national laboratories, to companies, to support the development of those technologies, to ensure that they use safety and safeguards and security by design, to enable them to use the kinds of facilities that we have at the national laboratories to do their materials tests and their, technology demonstrations, to do irradiation tests of those materials in test reactors, on federal sites with federal oversight and federal support. This allows our big federal capability to support those reactor designs as they're born from an idea into a commercializable technology concept. And then through other grants and funding opportunities and awards, either to communities or vendors, we can make awards that take those technologies and transition them toward real commercializable scale. And we're seeing that with the new Infrastructure Undersecretariat in DOE, which has the Office of Clean Energy Demonstrations, which has taken some of those advanced reactor companies that we in DOE-NE have supported and is moving them into the demonstration phase for real commercial demonstration in a couple of cases.
So should we assume then that all of these different advanced reactor types will eventually be deployed?
I'm an optimist, and so I don't see any reason why you couldn't, but certainly there can't, I don't think it's realistic to imagine that all of the incredible number of reactor startups and vendors will reach that commercializable scale. I think it's much more likely that a few will reach commercializability, you know, they have to make it through the incredibly high standards of the Nuclear Regulatory Commission safety expectations. They need to make it through the business cases that are hard to design. They have to have a realistic plan for how to manage their money and how to get to fuel concepts that work or coolant concepts that work. And not all companies will make it through that, but I think there are real opportunities, especially at every size range, to see deployment in the microreactor space in the 1 megawatt range, or the small modular reactor space in the hundreds of megawatt range, and even more gigawatt scale, 1,000 megawatt size reactors, I think, have a future in our energy transition.
So presumably that's
No, we're losing Kara.
once they are given the licensing through the NRC process as well. But what do you think are the biggest challenges? Do you think, depending on size, their challenges differ, or do you think that all advanced nuclear reactor developers are facing similar challenges?
I think in the very near term, most advanced reactor developers are facing the same near-term milestones. They need to make it through the Nuclear Regulatory Commission, except for, you know, NuScale and the AP1000. Most recently, the Kairos Hermes test reactors made it through its construction permit, for example, with the NRC, but that licensing I'll leave to John to talk through. But ultimately, the real hurdle is supply chain and workforce development and capital investment. You know, the commercializability of these reactors is going to really rely on getting to nth of a kind, so that the timelines and costs on which they can be built are predictable. They don't have to be the lowest cost, right? Because they're extremely reliable and low land footprint. And there's a lot of advantages to nuclear power that folks might want to pay for. But having a certainty about the timeline on which they can be deployed and the cost at which the electricity or the energy will be delivered is absolutely necessary for really significant capital investment by future customers. And until we get to that place, it's going to be a challenge for many of these reactors to reach nth of a kind. And so most of them are facing a scenario in which they need orders for the first few reactors in order to make a business case that they're going to get to that nth of a kind commercializability.
Fantastic. And safety, can you speak a little bit to the safety? We've named a lot of concerns, but some of the things we hear about out in the field, if you will, is, are these just as safe as the older fleet?
Yeah, sure. And of course, the idea here is that you don't learn backwards. The existing fleet is a very, very safe fleet, and everything we've learned over the many, many decades over which we've been operating fission reactors in the United States is being incorporated into a number of these reactor designs and improved. Advanced reactors are only advanced in the sense in which they advance some of these concepts. So we like to see things like natural circulation driven passive cooling in the event of an accident, for example, an off normal operation scenario. You want to see that reactor shutting itself down by physics rather than by human intervention. That reduces the reliance on human operators in the safety case. And this starts to get into the NRC space, of course, so I think we'll turn to John soon on that. But you know, we want to see that there's a real understanding of the largest consequence being limited to a very small geographical area. And the smaller you get those reactors, the more likely it is you might be able to achieve that very small emergency planning zone. Of course, all of this, again, is up to the NRC, but I think DOE has an opportunity to develop things like accident tolerant fuels and advanced, you know, fully encapsulated fuel types that incorporate silicon carbide and whatnot. The kinds of fuels that will contain fission products in an accident, so that the exposure to the public is avoided. Those kinds of things are real specific changes in the way that we approach the safety of these reactors that I think really offer promise in terms of the confidence people can have living in their vicinity.
That is technological advancements are very, very cool, and taking lessons learned and applying them is also very cool. Thank you. And Actually, let's go ahead now and on the subject of safety, and you've mentioned licensing, let's go ahead and introduce John into the equation. So John, thank you. We are looking forward to hearing from you next as we get into more of a regular discussion. And the first question for you is, what is the NRC's mission?
Well, first, Kara, thanks for allowing me to be here today. I really appreciate being part of the seminar, and Dr. Huff, really appreciate hearing your insights as well to kick off the conversation today. So let me start with the NRC mission, and I'll start with the simple mission and then expand a little bit. But our mission is to protect public health, safety, security, and the environment. When you think of the NRC, I think many times you think of reactors, but we do more than reactors. We have oversight of commercial activities, medical activities, industrial activities, but it really focuses on the commercial community. And what I mean by that is we have oversight of folks who are making business decisions. You heard Dr. Huff say a number of times in the advanced reactor area and the reactor area that there are business decisions. We're the regulatory side. We're not promotional. It is up to the industry to decide what type of technologies they want to use, whether they want to go nuclear, whether they want to look at the current fleet of reactors and continue with those designs. As Dr. Huff said, they're safe. There's an established process. As they move forward, they're going to look at the advantages of whether there's an advantage to go to more advanced reactors, different types of reactors. In doing that, we need to make sure we meet our mission and ensure that people and the environment are protected as a result of that. Also, while we're not promotional, it's also very important for us to make sure that we are not imposing any unnecessary regulatory burden. We need to make sure that we are providing the appropriate amount of oversight, the appropriate amount of controls, but not imposing any kind of additional burden that does not have a safety benefit to it or some type of benefit. But it really comes down to the applicants on their decisions, what technology they want to use. As Dr. Huff said, depending on the parts of the country, depending on the parts of the world, they may see advantages to moving to smaller reactors. They may see advantages to continuing with the current reactors. But our role stays the same. We're looking at the safety of the people in the area. We're looking at the safety of the operations. And we're also looking at the environmental impacts, and we review that as part of every application. Dr. Huff talked about the government's role overall. And I agree with her where the government's role is. And it's really great to have our two agencies on this call today, because she was able to talk about the role that DOE plays in assisting and moving forward with many technologies, whether it's advanced reactors, accident tolerant fuels, but it's a very distinct and different role than the NRC that plays a independent role in ensuring oversight of reactors through our rulemaking, licensing, and oversight processes.
Thanks. Yes, it's always great for us to be able to be working with both of the agencies that are engaged around this as potential host communities and to really understand who has what role. So given that this is the advanced nuclear technology in some cases is new, what steps has the NRC taken to get ready to license and provide oversight for them?
Great question. As noted already, we have a safe operating fleet of reactors out there right now that we provide oversight. We have a very well-established process for rulemaking, licensing, and oversight. But what we've learned as we continue to move forward is these advanced reactors are different. I think Dr. Huff said in many cases they're smaller, but there's not a clear definition. So I don't always think of them as necessarily always having additional enhanced safety features. But they are different in their first of a kind. From a challenge standpoint, the question was, how do we see all these different reactors coming out? Well, we look at it as we're going to see many first of a kind applications coming in. So how do you prepare for that? First is we really need to develop an established rulemaking process that allows us to look at a very technology inclusive, that will account for many different kind of designs, that takes into account very much the risk associated with those and allows for a performance-based approach. So when we look at being risk informed, our requirements are still going forward to say, you need to be safe. You're still going to meet our safety standards, but we have not imposed new safety standards on the new reactors when they come in. We do know that licensees are providing additional enhanced safety features. As Dr. Huff said, they're looking at innovative ways to ensure safety. They're looking at having passive controls in place. And we need to look at that as well to make sure that we account for that in our licensing process and essentially give credit for that allows them to maybe not have to meet some of the more deterministic requirements that we have in place. So we're looking at our deterministic requirements and saying, how do we make them more performance-based and make them part of a new rule process? We're also looking at guidance documents. A rulemaking process will go through a longer process, but we're working right now with the applicants to say, what type of guidance do you need in areas? What is it that you see as the additional safety features? Is it really just the size of the reactor and therefore your consequences being lower? Or do you have inherent safety features that now make some of our requirements obsolete and not needed for your design, so that we can work with them up front, hold meetings with them, and determine what are the appropriate requirements that we impose.
Great. So with all of that, how long would it take to get an NRC license for an advanced nuclear reactor?
That's a great question. We get that from many folks. Let me start with, it's been directed to us by Congress, actually under an act called the Nuclear Energy Innovation and Modernization Act, to establish clear goals and generic schedules for completing activities. Right now, we have established that the overall goal of that, to meet that act, would be no longer than 36 months. However, we set our sights a lot higher than that, and we try to work to have those applications reviewed on a shorter time frame. So we work with the applicants when they come in to understand what the scope of their projects are, how difficult the review may be based on its first of a kind approach. And we establish specific schedules for each of the reactors designs when they come in for pre-application meetings. I'm going to put a plug in here for any vendors who are online, that we really see a lot of benefit to those pre-application meetings, coming in and being able to state what your reactor looks like, what you expect, what your timetables are, and understanding from us what the requirements would be is very important. Dr. Huff just mentioned that we did a construction permit for Kairos Hermes 2. And I mentioned a minute ago that under our act, we're required to complete our reviews in 36 months. Well, in that case, we completed our review in 18 months. We worked with the applicant to understand what their need was. We worked in pre-application meetings to understand the scope of their applications. So we worked very closely with them on the front end so that we made sure they had a high quality application coming in. That's the benefit of the pre-application meeting. And in the end, even going through that process with a mandatory hearing at the back end of the process, we completed our review in 18 months. So we're very proud of that accomplishment.
That's great. And actually, one aspect I'm going to touch on right now is for both of you, and that is the role of state, local, and tribal governments on how they engage with your agencies around advanced nuclear issues. So I guess first, John, how is the public, how are local communities able to engage with the NRC?
Thanks. So public outreach, transparency has always been one of our goals ever since we've had our first strategic plan at the NRC. Our current strategic plan talks about inspiring public confidence. As part of that is our communication and engagement. Let me start with, as we develop I've mentioned for new reactors, our guidance documents, our rulemaking, it's a very public process. We make sure that we put proposed and draft language out, and that's for not just the regulated community, but for states, tribal governments, any members of the public can engage and provide us comments as we go through the process of developing those safety standards and licensing requirements for new reactors. In a very specific licensing case, we have two tracks that we go. We call two tracks of looking at the safety review as well as the environmental review. As part of the environmental review, we follow the National Environmental Policy Act and ensure we do our reviews in accordance with that act. That ensures we have an environmental review. As part of that, we have a scoping meeting. We actually go beyond what the requirements are of the Act by making sure not just do we have a scoping period, but we actually have a meeting in the vicinity of the site to obtain local stakeholder input. We coordinate with state officials and tribal officials in the area to make sure that they have an opportunity to understand what we're doing. As we go through the process, we issue draft documents. Our environmental impact statements are issued as drafts. Depending on the document and the amount of interest we have, we may hold a second public meeting to discuss the comments on that document and explain where we're going. From a safety standpoint, we ensure that all the meetings we hold with the applicants are open to the public. They have an opportunity to hear the kind of questions we're asking of of applicants coming in. They have opportunities at the end of the meeting to engage with NRC to ask what our processes are. And then finally, from a formal standpoint, all of our actions are subject to what we call a formal hearing process. Any member of the public, any member of a state, tribal government can request a specific hearing on a specific action. And that would go through what's a quasi court hearing type process where we have administrative law judges that are independent of the staff that it can hear the concerns and adjudicate any issues that folks may have. If I'd be remiss if I didn't say separate from this is we do have a tribal policy statement that the NRC has implemented, been directed and approved by the commission. That sets out the standards for the way we interact with tribes. We have a very good outreach system where prior to us even sometimes getting applications from applicants, we do outreach with specific tribes to talk about our processes, how if there were to be an application in their area, how they can engage with us, and really start those communications so that they understand our processes and don't have to wait until applications are in front of us to start that engagement. And then finally, as part of the NEPA process, we do follow the National Historic Preservation Act, ensuring that we meet the requirements of that act and have engagements with local tribes as well as state governments. And we also follow the Endangered Species Act to make sure that when we're interacting on the application, that if there's any awareness from the public of entering endangered species, that we can address that as well.
That's great. Thank you. Appreciate that. It's great to know that you don't have to make your way to Rockville, Maryland to engage. So that's fantastic. Dr. Huff, same question for you. And just an add-on to that, what about communities or tribes or states that might think they're already interested? What could they do now as they look to engage with DOE?
I'm so glad that we had this question because, everything John said, so much of it is also true of DOE. It's really important for us to engage with our partners and learn about their needs and, all of the things that are in the minds of any particular community or tribal nation. We have a lot of partners that help inform us. That includes ECA, but also tribal working groups and committees like the Nuclear Energy Tribal Working Group, the Tribal Radioactive Materials Transportation Committee, also known as TRIMTEC, the National Governors Association, the National Conference of State Legislators, NARUC, a handful of, groups. In our funding opportunities, we've recently begun across DOE requiring community benefits plans, for example, so that applicants for our funding have to plan out what benefits their project will have for the community. And so, what maybe has previously been limited to what kinds of environmental impacts we might negatively create through any kind of project across the DOE space and environmental impact statement space, NEPA space, we now include these community benefit plans as a requirement of application for funding so that we can identify that these projects are benefiting the communities that they're landing in. For your question in terms of, how can a community engage and is there funding to participate? There's a lot of different ways to engage DOE, and not all of the nuclear energy community funding is even executed by the Office of Nuclear Energy. Recently, we've begun funding a project that's sort of DOE-wide called Communities Leap, which is a funding opportunity that enables communities to kind of explore their own energy needs in the near term and look towards their own community level energy transitions and leverage the resources DOE has, some money that we can give out, national laboratory expertise, et cetera, to, make some plans for their energy transitions. We have a lot of informational resources and updates on our current and upcoming funding opportunities, but largely, I think, our funding opportunities for universities, for consent-based siting consortia, and a variety of other activities are like constantly being updated on our website. I would particularly direct folks to groups like GAIN, the Gateway for Advanced Innovation in Nuclear Energy. That group has been conducting some case studies around retiring and retired coal plant sites. We're really interested in seeing coal communities not be left behind. It's a real opportunity for communities around, former retiring or retired coal plant sites, where those sites may not have a future in the energy transition if they can't be mitigated by carbon capture and sequestration. But there are incredible resources in those communities, high voltage power lines that go straight to those locations. And, often there's sufficient cooling water for a couple hundred megawatts worth of reactor. And most importantly, of course, the workforce is there. What I and the secretary and everyone in this department really want to see is that jobs aren't left behind in this transition, and there are such skills at those sites that we could repurpose and reskill. And some are perfectly well trained to just go straight into a nuclear reactor, electricians and welders and boilermakers and deep turbine maintenance operators and whatnot. So that sort of thing, we really like to see. I'll just add a couple other things with regard to offers of resources and technical assistance that communities can specifically look at. Definitely the Communities Local Energy Action Program, Communities LEAP. These are competitively selected awards. The second cohort of awardees will be announced this spring, but there might be the possibility of a third round of applications. DOE's Loan Program Office recently established the Tribal Energy Loan Guarantee Program, which would certainly be a place to look if you're a tribal nation looking towards new energy resources, nuclear or otherwise. There's an interagency working group across the whole federal government on coal and power community economic revitalization. It has a lot of multiple resources for energy communities. We actively participate in this interagency working group. And I think you can find it at energycommunities.gov. But there are lots and lots of opportunities. And I think, it could be a great topic for a separate webinar.
Well, fantastic. I know at ECA, we try to follow a lot of the opportunities and make sure that the people that we get to share information with are aware of those things. Same with when there are NRC hearings, we like to try and publicize those things for folks. So if you're looking to find out when those things are, obviously check the DOE and the NRC websites, but there are lots of organizations that are also looking to make sure that people are aware when there are opportunities to engage. So we've talked a lot about what's going on in the United States. A quick question in terms of what's going on internationally. Are these advanced nuclear reactors deployed in other countries and working now? And that's for either one of you.
I'll say if you include AP1000s, which I do, there are a few AP1000s operating in China. The Unit 3 AP1000 is operating in Vogel, and Unit 4 has just gone critical. So very soon it will be fully operational, assuming it makes it through its remaining tests and whatnot, which I'm sure will. In terms of smaller, more modular advanced reactors and others, we've tested practically every coolant and fuel you can imagine out in the Idaho desert, like here in the United States. Other countries have a variety of other research and test reactors they've deployed. Very few exist in a commercial scale, but we've seen, for example, Manju in Japan was a sodium-cooled fast reactor at commercial scale. The US had high temperature gas reactor at a quasi-commercial scale. There's a handful of specific examples of one or two off kind of advanced reactor types that have deployed commercially. But at scale, micro and small modular reactors are just coming, right? They're at this place where we're at the peak of this commercialization, where, for example, NuScale has a design certification from the NRC, and this has enabled it to explore, for example, deployment in Romania, where they're very serious about replacing a former coal plant site with a NuScale reactor 12-pack.
Fantastic. Well, I know
Can
that.
I could add to that, Kara, if you don't mind.
Good.
Thanks. I really appreciate it. And Dr. Huff, I think, has a really great handle on what's going on internationally. But I did want to talk a little more about where the NRC has a role there and what we see. Let me start with at least one and two that Dr. Huff mentioned. With Romania and Poland as examples, right? We know Romania is looking at small modular reactors. We know Poland is looking at reactors. We have an Office of International Programs where we specifically work with the regulatory authorities in those countries. We work under cooperative agreements where we share the knowledge we have between the two countries of what we have as far as the knowledge of the technologies, what we see as the safety standards, what we've completed as far as our safety reviews. We consider that a real learning between both countries, especially when a country is getting its first nuclear reactor. We think it's very important that we share with them the information that we have, how we've set up our processes, and most importantly, how we function as an independent regulator from not only the commercial community, but also our independence from many of the activities with DOE. We also have worked very closely with Canada. There are some designs that we think are going to be deployed both in Canada and the United States in some of the smaller reactors. And we really want to learn about timeframes and scales for which we're doing that. Some of the smaller reactors we haven't talked about yet actually could be mobile, could be transportable. And when you're talking about a country to your border to the north and talking about reactors that could be moving, it's really important to have those international conversations with them. And again, as counting the AP1000s, I would agree. We're counting the AP1000s as new technologies, and it was noted, two of them just recently completing construction and going online and into operation. So I have to put a plug to our folks here for what our folks did, not only in the licensing side, but in the continued oversight of the AP1000s that were deployed here in the United States, because I think it really does show how we were able to look at a different technology, very much similar to what we have in the current fleet, but show that we can look at it in a very risk-informed way and ensure safe deployment.
That's fantastic. Thank you for that. And, given that you have so many people that might be interested in coming through the NRC licensing process, what does that mean in terms of your workforce? I know that we've talked about the workforce opportunities for the communities and the states and the tribes that might host a new facility, but surely you must be getting a lot of phone calls in terms of, hey, we would like to go through the licensing process of the NRC. So do you all have all of the people that you need to do that?
Well, it's great. Let me start with your workforce question and how we're getting there to accomplish it. And I'll call that a continuing challenge. And I think it's a shared challenge. I say that from the shared as we all have the same challenges, whether or not it's the NRC, whether or not it's the licensees and the vendors, or even the Department of Energy, is as you're starting to see interest in new reactors, there's not a lot of people sitting on the shelf ready to come out and step up, right? So we're all struggling to train folks and bring them on board. From the NRC, we've definitely put our foot on the accelerator in our hiring process of trying to onboard people. I think, as Dr. Huff said, many of the skill sets that you needed for the current operating fleet are going to apply in the new and advanced reactors. So we know the skill sets we need. We know we're going to need engineers. We know we're going to be scientists, physicists, health physicists, nuclear engineers. So we're bringing them on board. The other part of the challenge is having them understand the new technologies that are coming in. So the basic physics, basic nuclear science still applies, but you need to look at some of the new technologies, and we're not going to have just a standard light water anymore. We may have different cooling. We may have different types of fuels. So we're working right now on training courses, and we've set up training courses right now. We have internal training, as well as working with many contractors on, number one, providing us training support to our folks, but number two, supplementing our workforce with the specific skill sets that we would need moving forward. The most important part of that, though, is we need to make sure that we have the folks on board, trained, and ready to review the applications as they come in. And I would say that's another part of the challenge, and why it's also so important to work with the Department of Energy to understand priorities. If we were to just take every promise that we got from someone out there that they were going to come in with a new reactor design, and we were to staff up and try to have the technology on board for every one of them, that wouldn't be a good place to be, because we don't know that they're all going to come through fruition. We also don't know the timing of when they're going to come on board. So we need to make sure that we have the right folks in the right place at the right time. That's always been our motto in trying to bring folks on board. We do that by working with the applicants to try to get realistic schedules. I mentioned pre-application meetings, working with applicants to understand the schedules, identifying based on those schedules what our skill set needs and priorities are, and then making sure that we prioritize that work between applications as folks are coming on board. We think, as I said, it's important to work with the Department of Energy, because we think the Department of Energy has a real pulse on the industry of where do they see some of the technologies advancing a little faster? Where do they see a higher level of confidence of those coming to the NRC for applications? So that's how we're using that as one of our signposts out there to determine how fast to bring people on board and what skill sets to bring them into.
That's great. And actually, just to follow up on that, then, Dr. Huff, how does your office work with the developers as they're looking to get their license from the NRC?
Yeah, so a lot of our, funding opportunities are targeted at helping them develop their technologies, but some of our programs explicitly target things like materials qualification for the kinds of materials that are shared across lots of different energy technologies, whether it's a particular kind of fuel or a particular kind of steel. DOE, through our National Laboratory Resources, helps support some of the data acquisition that is necessary to put together packages to qualify materials under nuclear regulatory guidance under NRC, but we are very independent. And so the kinds of things that we do is generally support companies as they develop and hope that they make it through the NRC process. We don't really meddle so much, but I will say our general approach is to be very regulatory aware while simultaneously trying to help companies as they do technology development. I think on the workforce piece, there's so much to say, but, John said practically all of it. I think one thing I would just say, in addition to that, DOE and NRC have this shared university nuclear leadership program where we, make complimentary scholarship and fellowship awards. We also have Nuclear Energy University Program awards for research and development that support graduate students and faculty and whatnot across the whole range of universities, but it's not enough. We also need, K through 12 curriculum. So our DOE STEM team sort of tends to support lots of stuff like that. And we need way more than just nuclear engineers. We need, as was sort of said earlier, skilled crafts trades, construction trades, especially as we look towards deploying some of these, and our NRC knows this maybe better than anyone, that, Vogtle required thousands of people. They had to train up. I mean, at peak, I think they were at 8,000 people or something on site in Georgia, in little Waynesboro, Georgia, right? And because not all of them, were the same 8,000 people over the whole course of the project. It's something like 13,000 total people who worked towards building this pair of reactors out there in Georgia. And, it's not a huge surprise, right? I mean, we're in a scenario where there's just a lot of jobs that are going to be involved in the energy transition. This administration has seen an incredible increase in job availability. There have been 14.8 million jobs added since January 1st of 2021. There were 353,000 or something just last month. This is the longest period of unemployment under 4% in 50 years, right? It has been an incredible push, and we're barely getting started in terms of the amount of building and construction and like energy build out, not just for nuclear, but solar, wind, geothermal, everything is going to be needed. And you can already see that change in the number of jobs that we're talking about. And so anyway, on the workforce front, I mean, we're hitting records and we're not even started.
I know our communities are super excited to ensure that they have workforce development programs around what they hope will be new sites for new reactors as well. So it's always exciting to hear how focused each of you all are on
Eric,
making sure the workforce is there. Of course, yes, please.
yeah, if I could add, as Dr. Huff talked about working with the DOE national labs, I think that was also an important point there that I share. While we continue to be an independent organization and look at applications from a regulatory standpoint, a lot of the research that Dr. Huff talked about is what I'm going to say is very more generic research, right? The materials of construction don't know who's looking at it, whether it's the regulator or DOE or the commercial entity. And sharing the information and data from that, I think, is very important. And that is something we've definitely built into our programs as well, is making sure that we work with DOE to share the raw data that we have from that. So that really helps to say that not only are you sharing the data, but you're sharing the scientists who actually worked on that, because the scientists, again, they're not looking at it from the standpoint of a regulatory standpoint or a promotional standpoint or a vendor standpoint. They're looking at it as scientists, and we can definitely share that data, and that helps, I think, all parties involved.
I know definitely for us on the outside, it is a very positive thing to know that the agencies work together, because oftentimes in the past, you see how stovepipes can kind of prevent progress, or at least efficient progress. So it's really great to hear you all say that, both of you from both sides of the aisle. So you made a comment earlier about the AP 1000 in a little town in Georgia and all of the jobs. Do advanced reactor technologies, can they go into rural communities? How many households can they power? Some of these little details. Can you fill us in on those aspects?
Yeah, sure. So I think we're in a space where we're really seeing a lot of vendors looking towards deploying right where they're needed. And sometimes it's going to be right where a coal plant used to be. And sometimes it's going to be in a more urban environment than we've envisioned in other cases. It's going to depend on NRC decisions around the emergency planning zones and the site location. Like, each reactor is going to have to go through a process of site approval through the NRC, but a lot of them are targeting more sort of site boundary containment of the largest consequence. That's certainly a goal of many of the designers. And we would really love to see that, because it could enable much more flexible deployment if it comes to pass, right? And I think that matters, right? In terms of size, I'm really terrible at talking in terms of households. I should have this in the back of my head, but in terms of megawatts and gigawatts and whatnot, you can think of the entire nuclear reactor fleet is about 90 to 100 gigawatts. That's about 20% of our total power. So you're talking about a scenario in which our total electric grid is like 500 gigawatt scale reactors, if you wanted to do it that way. Any small modular reactor is like 1/3 of an existing reactor, right? So you can think of it in those sort of gigawatt terms, because different households, it turns out, are different. I know there's like a standard, and I should start talking that way, but I just can't bring myself to do it. Someone else can probably do the conversion for me, but in terms of the size that you would need for a small community, for example, a university, like a research R1, like a Michigan or an Illinois that has students living on campus, and they have 100 buildings, and they have classrooms, and they have research spaces, they have cafeterias, and many of them operate their own fossil plants. Those sizes are going to be in the 50 megawatt range. Some campuses may require both steam for their steam tunnel systems and electricity for their electric grids. Some of them will then have something like in the tens of megawatts worth of thermal load, plus tens of megawatts worth of electric load. Some of the very big universities really, they reach pretty high numbers. When you look at like a Argonne National Laboratory exascale computing machine, you're also talking about sizes like that, right? So we think about data centers and things like that, and that's in the tens of megawatts, maybe even hundreds of megawatts in the near term, right? And so that's in the micro to small modular reactor range for each data center or university campus, for example.
And the modularity means as more demand comes, then you can perhaps add another module as well, right?
Yeah, and that word really targets the construction approach. When I hear about someone's small modular reactor design, what I'm hoping is that they're thinking that their construction approach will include rolling skids of, most of like finished reactor construction parts onto, a truck, delivering it onto site, and then kind of snapping those modules together in a sense so that you're not laying new pipe in a boutique way at each site, but rather you understand the plant layout and you have a factory where you're assembling those skids, you deliver them on site and you build it modularly. And so from my perspective, that kind of modular statement, enables adding new modules of reactors because they're sort of plug and play. There's, if you do it right, then there should be a nuclear reactor factory and you assemble on site instead of construction. Hopefully it makes it easier for NRC because they only have to be, mostly at the factory rather than every site across the country at all times. Though I'm sure you will be.
John,
Yeah.
did you add to that?
Yeah, I'd love to. There was I really appreciate it. Let me start by saying I'm not going to be able to help Dr. Huff by saying how many households, because I don't have that kind of number either, and we usually don't look at it from that perspective. But we understand that's where the business case comes from. From our standpoint, we understand a lot of the issues, in whether it was talking with DOE or talking to the vendors. The issues that Dr. Huff brought up are what we hear as the key issues. What are the requirements going to be at the site? What are we looking at from emergency planning? What are we looking at from security requirements? Items that make sense from the larger reactors, that the question is, do they make sense from a necessary standpoint for the smaller reactors? And let me say, we're going to make the right decision. If they do make sense and we need to do them, we'll do that. In many of these areas, we just haven't made the decision yet, and we're still looking. But the vendors need that certainty, because if certain items are a showstopper for them, that changes their direction on where they want to go. We're looking, I think the term Dr. Huff used was, plug and play. I'll say a little differently is we kind of look at those as, are you looking at those pre-manufactured units that can be shipped? I mentioned a little while ago in our conversation that we hear people talking about transportable reactors or mobile reactors, but we look at those that Dr. Huff just talked about as well as being, what are those smaller units that folks are coming in saying, I want to manufacture this, but I want to do it all at my vendor facility. Have NRC come do all of its inspection here, do all of its pre-licensing visits, so that the environmental aspects are the only thing that need to be looked at in the site, and they can just take it, move it, put it in place, and start operation, kind of, a turnkey operation when they get there. That's new for us. And there's some policy implications of that. And we recently have provided a policy paper to our commission on that, on how do we move forward in that area? What does it look like as we continue to move forward in those types of issues? Because we want to make sure that the vendors have the certainty on where we're going. Is that type of business model something that they can work with while still meeting our safety, security, and environmental requirements?
Great, thank you. I am now going to start to transition over to let people other than myself ask the questions. But I do have one last question that I want to ask John before we go to the audience. And that is, if a license application fails at the NRC, does the vendor get to try again, or is it one and done?
Thanks. So the short answer is they get to try again. But let me talk a little bit, if you don't mind, a way we normally see this happen as we continue to move forward. And that is, we continue to have a lot of interaction between the NRC and the vendor, applicant, whoever it may be coming in. And typically what we find out is there may be one or two issues where the license application may not be meeting our safety standards, may not be meeting our security standards. And typically in that case, what we see is the vendor would typically make a change to the application to meet the standards. So it's very rare that we see that we would deny an application for that reason, because it's the transparency we have with them and the members of the public of, this is the part of the application that needs to be supplemented, needs to be changed. And typically we find that's what the vendors do. They go back and make the appropriate changes. If they find that it's something that's just not worth doing for them, they may withdraw the application. And in some cases, they may decide to, well, we need to think about it and do a withdrawal. So in those cases, they can clearly come back to us and say, we want to resubmit our application. If we deny the application, it really depends on what the basis is that we've issued a denial. If we've made a clear denial that this technology does not meet our safety standards and we're clearly denying it, they have rights to come back and request a hearing and challenge our decision. I mentioned that members of the public have a right to go through this hearing process, which is a quasi-court type process. Applicants can do that if they don't like our decision. What we find, if they go through that process, again, they could pull out at any time and say, no, we're going to make changes and come back. So I think, yeah, as I said, the short answer is they can come back, but it depends on which process they go through. But it's still going to be us verifying in the end that they still meet all of our safety standards before we would issue a license.
Thank you. Really appreciate the discussion that we've had thus far. And now I want to give it an opportunity to the folks that are listening to ask questions. As we are transitioning to that, we're just going to pop up 2 more interactive polling questions so that we can gather more information about who we get to talk to and what we get to talk about next. So as we do that, I'm going to go to the chat and start to pull some questions. So the first area I'm going to raise is for both of you, and I'm actually going to keep it a little broad. There are a number of questions in the chat that are talking about nuclear waste. So for either one of you, can you speak to advanced nuclear reactor and advanced nuclear reactor waste and how that is being addressed and how we're talking about it? Anybody want to go first?
I can touch on it a little bit. You know, we're in a space, of course, where DOE is focused right now on primarily identifying a pathway that can work on consent-based siting for our existing commercial spent nuclear fuel, consolidating all those locations into a single or maybe 2, you know, interim storage sites across the country, hopefully to reduce the number from 70 to like 1-ish consolidated interim storage facility. And most of the, you know, all that fuel, generally speaking, we're talking about light water reactor fuel. A lot of small modular and advanced reactor types will use that same kind of fuel, but some of it won't. And so we also have a program in our nuclear waste office that's sort of spinning up a lot more attention on management of our plans for waste form acceptability, and the waste form acceptability criteria question, of course, then leads to NRC space, but working on ways to make sure that all of the different kinds of reactors, that whether they have tri-structural isotropic fuels or molten salt fuels or metal fuels, or, you know, the whole variety of different kinds of fuel forms that we're looking at, they should all have some acceptable waste form that is appropriate for final disposal. And obviously this is a many-phased approach, but, you know, we have familiarity with these materials, but assuring that they can be stored and disposed of safely does require a few steps per reactor, and we're working on expanding our work in that area. But John, maybe do you want to say anything about waste acceptance criteria?
Yeah, thanks. Really appreciate that. And thanks for going first. And Kara, thanks for the question. And I'm actually going to go back to maybe where Dr. Huff started the original question, our first question today, talking about the operating fleet. And I'll speak about the nuclear waste in the same sense. Right now, we do ensure that the nuclear waste is safe and secure. Some of it, whether it's at current operating plants, whether it's at independent spent fuel storage installations, we continue to ensure and maintain safety. What we also do are we're learning a lot from that management, right? I should have off the top of my head the number of storage facilities and the number of casks we have out there right now, but we've learned a lot over the 30 plus years that we've had spent fuel storage, not just in fuel pools, but I'm talking really about the dry storage now. We've learned a lot about the way the fuel reacts over time. We've learned a lot about the cladding material. We've learned a lot about the cask themselves. We've done a lot of testing. Stress corrosion cracking has been a high area of interest there. So we've learned a lot about the materials of construction of those canisters. As we continue to move forward in the advanced reactor area, we're taking the lessons of what we know, and also I'm going to say what we don't know. What are the unknowns there? And while everyone is, you said, very excited about the possibility of these new technologies, we're looking at the entire fuel cycle. As the director of the Office of Nuclear Material Safety and Safeguards, one of my primary roles is the front end of the process as well as the back end. So we're working today, and the timeline, I think, for most of the vendors is to get the fuel certified and into the plants, because that's the front end to move it forward. But at the same time, we're already looking at the back end. We're working with our Office of Research. Our Office of Research has been in coordination with DOE to understand what activities they're doing, to really say, what do we see as the end life as they continue to move forward of this fuel coming out of the reactor. We've looked right now at whether it's wet storage, whether it's dry storage, what the type of fuel looks like. But we really look at what are the scientific challenges we had on the first set of reactors, how does it apply to the second, and how are we filling those knowledge gaps. The other part that we're seeing an interest in is whether or not people are looking at doing any reprocessing as part of continuing to move forward. And that's going to be another area that again, from NRC standpoint, as the independent regulator, we're not dictating whether or not the fuel should be reprocessed or not. But we do see an interest out there. People are saying, can we do this? If we do this, how do we do it? And really, the market's going to drive that and say, is there an appetite from the standpoint of the financial side to reprocess this fuel? If they do it, we have processes in place to do that review and approval and make that determination. That also changes the waste profile, though, as well, whether it's taking the current fuel or fuel out of the new advanced reactors. And we've already been looking at that. So if I were to look at a lot of the research dollars in my office right now, different than the office that looks at the reactors themselves, we're probably spending more research dollars on the back end of the process than we are on the front end of the process, because there's more unknowns there than there are on the front end of the process.
Fantastic. I mean, at ECA, we definitely like to push for a holistic approach to all of this, because we have people so excited about the new stuff, people who want to safely see the old stuff be taken care of. We know we technically can do it. So it's just having that conversation to get the policies in place to make it happen. But it's exciting to hear that everybody is looking holistically at the fuel cycle. And in fact, reprocessing and recycling has come up a lot in many of the questions, as I'm sure surprises nobody. But the fuels, let's go back to the fuels really quickly if we can. Can you talk a little bit about accident tolerant fuels? We didn't really get to the way that the fuels have changed and advanced themselves and the fuel situation. So again, for either one of you that wants to take that, if we can talk a little bit about accident tolerant fuels.
Yeah, I can say, NRC has a great page on exactly what accident tolerant fuels are defined as according to the NRC. So I recommend, checking that out. Ultimately, these are fuels that make a reactor more resistant to a nuclear incident. Usually these are fuels that have an advanced coating or an advanced material that's going to elongate the time over which those fuels can avoid any kind of fission product release, even in the event of quite divergent temperatures and pressure profiles. So that's great. And we have a very long running industrial collaboration for light water reactor accident tolerant fuels. We also have a number of other fuels that I think you could describe as accident tolerant, but are in sort of the advanced technology fuel space. So, as you start to think of the bigger, broader umbrella, the same acronym can be applied. But tristructural isotropic fuels that have really hardened silicon carbide coatings around all of the uranium in teeny tiny little kernels. So you have teeny little kernels of uranium, the size of a chia seed. Coat that with one of the hardest materials known to man, coat it with additional materials, and coat it again with that very hard silicon carbide material. And you end up with these like very robust materials that can withstand incredibly high temperatures for incredibly long periods. The heat fluxes that they can withstand are just incredible. And this really gives you confidence that even in far from operational temperatures, you would withstand any kind of increases in reactivity and long-term temperature increase. So those kinds of things should give you great confidence that, the dangerous stuff, the fission products that you don't want entering the environment will stay right where they are. And this is what we'd like to see in such fuels. Does that help? Oh, go ahead.
Yeah, let me start. I want to thank you for plugging our webpage. It's great to not only have folks look at our website, but then reference some other folks later. So really appreciate that. Karen, I'm probably going to give a very long answer, but I'll try to keep it short. But I'm going to start from the beginning and say, one of the areas I talked about the front end of the fuel process is we have a responsibility to make sure that during fabrication, right, that workers and the environment in those facilities are safe. Dr. Huff talked about the fuels right now and said hardest material known to man. Right, there's a lot of safety features to that once it's complete, but in the processing of it, we do have to make sure that any potential hazards there are addressed as well. So you are talking about certain enriched uraniums, you're talking about other types of hazards. You get into a lot of chemical hazards in that area as well. So the NRC makes sure that during the fabrication process, we're protecting people in the environment there during the initial fabrication. Going into the reactors themselves, if you think about the accident tolerant fuel, some of the easier items to address maybe are the fact that you deal with increased enrichment. We've been dealing with enrichment for years. We know how to address criticality. We know some of the impacts of that. We look at the fuel itself and whether or not the initial cladding is going to continue to maintain, whether or not it's going to maintain containment. We address whether or not it's going to meet the standards that are advertised for this accident tolerant fuel, because we need to make sure that if it is meeting those standards, folks are doing that because they're also looking at some potential benefits where they may get relief from some of the NRC regulatory requirements. So we need to make sure from a quality assurance standpoint that they're actually living up to what's billed and advertised as what they're to accomplish. And then the other part that I think sometimes people don't think about is when you put it into the reactor, maybe the cladding would survive in these accidents, but are you going to have any potential where if you're putting a coating onto the fuel itself, well, is that coating going to leach off into the coolant? Does that cause other problems down the line within the reactor? So we look at it from a process standpoint, not just of will the fuel maintain it, but in the reactor itself, how is it going to react? How, if there were an accident, what is going to happen with respect to that accident? If in the testing part, we look very much at testing of the materials. We look at the material science involved. I talked about our coordination with DOE and the labs on a lot of the testing activities. But the final part is we do a lot of lead test assembly work as well. And in doing that, it allows us to take very small fractions of the core, place this accident tolerant fuel in place, allow it to actually go through an operating cycle. And then we benchmark that from testing that material to see and confirm that it meets the standards that we had tested already and have been demonstrated that folks say it would meet. So it's not just a paper review of it. We do a lot of real-time testing of it, and then we do benchmarking validation against it. It's only after we complete all of those activities would we then say it's safe to approve this to continue to move forward into a larger operation.
Right. I mean, listening to what you're calling a long answer, it all contributes to why the NRC is considered a blue ribbon regulatory agency in the world. So appreciate you going into that detail. And to take off from there, so then how will FEMA and offsite responses that currently exist for existing reactors, will those processes change as well?
Thanks. So I'm not going to speak for FEMA, okay? And again, I'll speak for the NRC and our planning. We are looking at that, and that is one of the biggest questions I think we get on the advanced reactor side. And our philosophy is to make sure for all of our requirements, whether or not it's safety, security, emergency planning, that we right size our requirements and our responses based on the hazards that we're seeing at the plants and what we've evaluated. We're continuing to look at that through potential rulemakings right now as we continue to move forward. I mentioned at the beginning of the conversation, we have a rulemaking that's looking overall at we call it Part 53 for advanced reactor technology. So I don't have the final answer on what this is going to look like in the future, because again, we need to look at where these requirements are going to come out in rulemaking. And then we need to look at each of the applications to determine their applicability and whether they can meet the standards or not. But I feel very sure in saying that just like many of the other requirements we have at our larger scale reactors, we need to make sure that we right size the response that we have to the hazard and the consequences that we're dealing with. I said I'm not going to speak for FEMA, but I will say that we're going to continue to coordinate with them. Just as we're talking about coordination with DOE and an understanding, we need to make sure we coordinate with FEMA in understanding how they respond as well. And then I brought up FEMA because you mentioned them, but I think we also, the part is, and as part of the purposes call today, is we also need to coordinate with the states and the tribal nations, right? These are the communities where these advanced reactors are going to be located. So as we go forward and make our policy decisions, whether it's rulemaking on what the emergency planning looks like, whether it's specific license amendments to what the requirements look like, we need to make sure we're engaging those local communities to understand their concerns and to make sure that we adequately address them in our regulatory decisions.
Fantastic. Thank you. Looking at the Q&A, there are also a number of questions related to leveraging past experience, specifically in regards to the Navy and the nuclear Navy. So maybe we can talk a little bit about siting and opportunities for siting, which is a theme. But we've got a lot of folks actually talking about, would you site near ports, basically, where you have naval nuclear reactors, you have the manufacturing experience, and you could create the jobs there. What opportunities might there be to leverage the history that we have with smaller nuclear reactors like the Navy used, and apply them going forward, and also give new opportunities to smaller communities like those ports that have some experience and want to leverage their existing workforce and knowledge?
I'll say sort of two things about this. One is that I think, yeah, there's lots of supply chain that's shared historically, and workforce and whatnot that's shared historically across between the naval nuclear reactor space and the civil nuclear reactor space. And so a universe in which naval bases particularly need a resilient source of energy, I think we would love to see micro and small modular reactor deployments in support of naval bases and Air Force bases and Army bases. And a number of the different arms of the military are looking at that. I've had the honor and privilege to meet with some of my counterparts in the energy space for they're like assistant secretaries for energy deployment in each of these sectors of the military. And I've gotten to meet a few of them and talk about what their plans are for making sure that those bases have energy. Naval bases would be a natural fit for such things, but naval reactors are somewhat different than commercial small modular micro reactors, and I fully expect them to continue to be somewhat different, but where there are shared component types and component manufacturing requirements, and workforce pipelines, I fully expect we can and should and will need to leverage those. So I guess I kind of blended both of those things, but my two things are like, we definitely have always and should always, I think, share workforce and component and supply chain manufacturing across these two sectors. But then also, when we look at the opportunities for deployment of commercial reactors at a smaller scale, we look directly at those critical infrastructure locations like the military bases, which need resilient, clean power. So there you go.
Fantastic.
Thanks. Yeah, as I said earlier, we at the NRC, we don't decide what technologies or where they get cited. That's up to the commercial side to make those decisions. We are engaged in making the final decision of whether or not it's safe for the people in the environment. When we think about, you mentioned naval reactors a couple times. We do not regulate the naval reactors. However, we do work very closely with naval reactors on sharing of information, sharing of our insights, and they ask for advice on us at times on reviewing some of their technology. So we're fully aware of that, and we have an understanding and can use a lot of that information in making safety decisions as we look towards some of the smaller reactors. I would also say that an area we do regulate is research and test reactors at many universities, which again are very similar to what we're talking about as far as the size of the core and being smaller, some of the hazards being much lower. Things we talked about a little while ago as far as some of the requirements are not the same on those reactors as you have on the large reactors, and we're going to take a lot of that in making our determination on siting as we go forward. You mentioned the need to maybe have naval bases. Sparked something that I did want to bring up today is we also see these reactors being used in more remote areas. That's where we're hearing folks come in and say, as they continue to develop the smaller reactors, more modular reactors, they can be moved to more remote areas that need electricity. And one of the things that we look at as well when we do that during our environmental review is environmental justice. It's very important to look and do that evaluation. As an agency, a couple of years ago, we relooked at our policy for environmental justice. We found it's served us very well as part of our NEPA process and doing our siting evaluations. We did provide a paper to our commission on some areas that we could look to expand and improve in that area, but we determined it's a very robust process, and we will continue to follow that through siting. So it's not just, when I think about the number of reactor sites we have across the U.S. today, it's probably pales in comparison to what the vision is for the future and the number of different reactor locations you'd have across the United States in the future if the small modular takes off the way many are predicting. So we do need to make sure that we look at those aspects from the siting, but we would not be directing that in any way. That's up to the developers, that's up to the vendors to decide where they want to sell and deploy their technologies.
Great. I have time for just two more questions, I think. So I'm going to shoot one over to you, Dr. Huff, from here. And that is the DOE Loan Program Office provides some great options, but it is still somewhat limited in what it can finance. Can you share your thoughts on what public utilities, small IOUs, and et cetera, what can be provided to them? What kinds of tools might be available to them to help develop these projects in the time that it's taking to get to nth of a kind, if you will?
It's a hard problem, that situation. I think those smaller utilities especially may not be the right mover for the first of a kind. I mean, we want to see aggressive, hard, fast movers on the first round. But I think we've seen, and this is being quite frank, with the carbon-free power project and the way that its business model did not succeed, I think it is a reflection that of all the things that sort of could have gone wrong, what really kind of did go wrong is the ability for the subscription model, the committed early stage capital in a very strong and liquid way in the early stages of that project, what was sort of the weak first link that didn't make it through. And that I think can be avoided with larger customers with more liquid and patient capital available. And so you may find that being a fast follower is right for those smaller utilities and not so much a fast first. Those fast follower opportunities, I think, will benefit from a number of things. I would specifically say that, unfortunately, it's not been appropriated yet, but there are some provisions in the CHIPS Plus Science Act called Vision for the Future. This is in Section P, that describe a program in which we could expand the kinds of community and vendor support that we've historically supported through the industry funding opportunity announcement, but focus on communities that are retiring coal plants and fossil sites, and focus on the kinds of activities that they may need in the early stages, and focus on the finalization of design and potentially even early site permits and those sorts of things that would be the first steps for some of those communities and customers that don't have that sort of massive first of a kind capital today, but are maybe looking at it in the next couple of years. We would love to be able to deploy that program, and we're pleased to have the authority to do so. It hasn't been appropriated yet, but I think when I think about what a program could look like that directly supports some of those ambitions, it looks just like those Vision for the Future provisions in the CHIPS and Science Act.
Great, thank you. So I guess the last question I'm gonna leave out there is, when do you think we will see advanced nuclear technologies deployed in the US? A guesstimate, if you will.
Yeah, I think, the first of a kinds are coming right at the end of this decade. And if we don't proceed rapidly into the second, third, fourth, fifth of a kind in the years just following those first of a kinds, we will not be able to hit net zero. So whether I believe it's possible or not, it is absolutely necessary that we deploy reactors in the many tens per year by the time we're hitting 2035, because otherwise we will not reach our net zero goals, and the worst impacts of climate change will not be avoidable. So I personally would like to be around in a pleasant environment in 2050. And in order to do that, we're going to have to see reactors being commercialized and connected to the grid in the 2035 timeframe at the beginnings of commercial scale.
John, how do you feel?
So let me, as you've heard from me many times, Kara, right? We're not going to be promotional here. Not going to try to predict the future. It's very much the vendors. I appreciate what Dr. Huff said, and I understand where the administration, the federal government's going overall. I will say that I think that the NRC has shown, as we move forward, we've got some great examples where we have demonstrated that we're ready to respond to the challenges as we move forward. Vogtle 3 and 4, right in front of us. NuScale approval. Many of the lessons learned out of NuScale. Kairos Hermes 2. That took a lot of what we brought out of NuScale. When you think about first of a kind applications, Dr. Huff said this, you're talking first of a kind. And I like that she says, when you get to the nth, number, right? We're going to get more efficient as we get there. Those first ones are the ones we're learning from as well. And we've already demonstrated that we can learn from what we learned on Vogtle, what we learned on NuScale, what we adapted to Kairos Hermes, that we can get there from the standpoint of ensuring that our regulations, that our oversight is right-sized where it needs to be. So I think it really is going to be where the industry comes in, where the need is. I would not argue at all what Dr. Huff said about where she's going, but from a non-promotional standpoint, I think we are ready to change our processes to make sure that they're right-sized to support continued public health and safety without being a hindrance in any way.
Well, I can tell you that ECA will be more than happy to provide as many platforms as you all might want. And I know that we have partner organizations that we work with that represent tribes and state policymakers and governor's offices as well. So to the extent that we can help provide the audience, I know that everybody would love to hear more from you all. So thank you for taking the time. Just to wrap things up a little bit, there are clearly so many issues, and we didn't get to half of the questions that have been raised in the Q&A. So we will definitely be doing more, which brings me to our final interactive polling that's going to pop up on your screen. And it's going to give you some issues that you'd like to hear more about. Some of them we've touched on, some of them we didn't get close to, unfortunately, or we could spend many hours talking about any one of these subjects, I think. But what we've heard the most so far in the Q&A is the life cycle of advanced nuclear project, that understanding that is a key interest. Siting these facilities is a key interest. Reprocessing and recycling, understanding the feasibility of it. What is the actual outlook for that? We know that it's come up in the past, so it's back. So people have asked a fair amount of questions about, is this the nuclear renaissance? Are we here again? Can I say again? I'm not sure. Are we in a nuclear renaissance moment, maybe? We sure hope so. And we really appreciate the information that you all have provided. For all the folks that didn't get your questions answered, please find a way to get in touch with ECA in the announcements that for this session today. There are contact information there, and you can send us email, and we're happy to follow up. And I know that there are further questions for Dr. Huff and Dr. Lubinsky as well. So we'll try and collect all of that information and get those out to you, those questions, so you know where the questions are coming down, and also so that we can help provide any answers if we possibly can. And then the last thing, in a moment of pure shameless self-promotion, not only have we asked Dr. Huff and Dr. Lubinsky to be here on the call today, we are also hoping that their offices will be represented, at an ECA meeting that we are hosting in May in the Tri-Cities in Washington. It is part of ECA's new nuclear forum. We incredibly appreciate the support from the Office of Nuclear Energy at DOE for us to put on these kinds of events. And it is essentially part of what we call our new nuclear initiative, which is to help define the role of local governments and local governments, elected leaders at the state level, at the tribal level, to all talk about nuclear energy, new nuclear energy holistically and together. Because it takes a lot of us to make these things succeed. And by working together at the same time in the same room, not in silos, we think we have the most chance at progress. So the meeting is open to everyone. If you are a community that's considering nuclear, please get in touch. We have some resources to help people participate, and we want to make it a really excellent meeting. The NRC and the Office of Nuclear Energy are on that agenda already. So we will definitely be able to continue some of these conversations. That's May 8th through May 10th, with an optional tour around the Tri-Cities in Hanford on the 10th. And again, more information can be found on the ECA website. With that, I want to say thank you so much to John and to Katie. Your time and your team's time and preparation to do this has been fantastic, and we feel very lucky to have brought this to the masses today. Thank you so much, and I hope you have a good afternoon.
Thanks for having us.
Thank you, Carrie. Karen, thanks, Katie. You have a great afternoon.
You too.
Thank you. Bye-bye.